All right, good evening. So about 100 students still haven't accepted the invitation to join ED. So if you are in this class or if you are watching this recording and you haven't accessed ED already, it's probably time to do so. Some of you have started asking questions. That's very good. Try to choose the category properly, because now it's all under general, right? So I have edited some labels. I changed to notes. So try to be careful, especially when it comes to the assignments and quizzes. That's the categories, and then you will have subcategories, quiz 1, quiz 2, and so on. It obviously makes it much easier for us to find what we want, right, if we are careful and keep things organized. So try to be a bit disciplined with this, please. So tonight we'll continue our work on the Turing machine and extracting the heart of this widget and learn a lot of Python on the way. Then I'll talk about the quiz and a bit of practice if we have time. So let's open a Jupyter notebook sheet. Right, I just gleaned what we wrote on Monday. So if you remember, we defined a list meant to represent the tape. So here, for instance, we'll have a fraction of the tape, of course, a finite segment of the tape. So 3 zeros followed by 7 ones, followed by 2 zeros. And then we thought it would be nice to write a function that lets us display this tape in a nice way. And we designed the function to first draw a horizontal line, then display the tape contents, draw another horizontal line. We implemented this second function, and now we don't need pass, right? So our function, display tape, calls, executes twice this function that prints a sequence of 2 times length of tape, so number of elements in tape, so 7 plus 3 plus 2 plus 2, so 12 plus 1 hyphens, right? So execute the contents of this tape, of this cell, that one, and that's where we are. Any question so far? Any question on what we did last Monday? Or? No? So, if you remember, our task is to do something like this. So we have the hyphens at the top. And then we want to have the contents of the tape, so 0, 0, 1, 1, etc. Okay, with vertical bars separating. So I should, let me. Right, so vertical bar, bit, vertical bar, bit, vertical bar, 1, vertical bar, 1, vertical bar, 0, vertical bar, something like this, right? And then our hyphens, which are above the vertical bars, and the bits above and below, right? That's what we want. So we've done this, we've done that. So now we need to take care of these bits with the separating vertical bars. So how can we do that in Python? Well, Python has a method of strings that help us glue together a sequence of strings. So if I have a sequence of strings, let's say, how are you tonight? Okay, so a list consists with 4 elements, 4 strings, right? Now what if I want to get from these 4 strings a single one, gluing all these strings, all these words, with what would be a good glue, I guess, a space, right? So we can do that by saying, here is our glue, a single space, and this string has, like all strings, a particular method, which is join, that, given as argument a list of strings, will glue all elements of these strings and return a new string, right? So if instead of using a space as glue, if I use A plus B join L, I'll get this, right? So A plus B inserted between any 2 consecutive elements in my list. Okay? Can I glue all these words without anything in between? No space, no other characters? Yes? What should I use then? I should just use the empty string, right? So between single quotes, nothing. And now I can join L. Okay? So maybe we want, so what kind of glue do we want? What is the glue we want? We want vertical bars, right? So let's try this. Vertical bar as the glue to join all the members of tape, right? And there, that's tape. It's this list. We want to glue all these elements, all the elements of tape. Well, that's successful. What does Python complain about? That we try to glue together not strings as expected, but integers, right? Tape is a list of integers. So what we would like to do maybe is to convert this list of integers, right, into a list of strings. And then you could apply the join method. So if we have an integer, like 12, so we see that 12 is an integer with type, for instance. It tells us the type of 12 is an int. Now we could apply the str function, and that returns the string, right? So the sequence of characters that make up the representation of the integer 12. And the type of str of 12, see, is a string, what we want, right? So distinction between integer and sequence of characters that correspond to the decimal representation of our number. So, of course, we want to convert not one integer, but quite a few, all the members of tape, into strings, right? So we want the list, string 0, string 0, string 0, string 1, and so on, right? So how can we do this? we can use what is called a list comprehension, right? So Python is easy if you start to read it naturally, right? It's very mathematical, so I'm sure you have written things like the set. We can say that 2n, right? That's the set of all integers, so all natural numbers, right? So such that n is even, right? The set of all n such that n is even, right? That's kind of thing we write in maths. But Python uses the same kind of syntax, right? So we can have the list of all things of the form str of e for e in tape. Now we have a list of strings, right? So it's important to spend a bit of time reading that naturally. The list of, right, everything of the form string of e for e in tape. So if you like, with e ranging over tape, right? For e being first the first element of tape, then the second element of tape, and so on, right? So just feel comfortable, read that in a way which is natural to you, and then you find Python quite natural and easy. Okay? So now, what do we have to do? We have to apply our glue, right, to join precisely this. Okay, you see, this list above now is a list of strings, so we can create a new string by gluing all its elements with the vertical bar. Is that fine? So we still want vertical bars at the beginning and at the end. So I guess for that we can just add a vertical bar at the beginning using the plus operator, right? So high plus there creates a new string, right? Which is the concatenation of both. So in other words, if I write this, let's have a vertical bar. Let's concatenate that with the big thing, and eventually let's concatenate that again with a vertical bar. Then we've got what we want. Okay? It looks good, but it's not good. Right? So that's where I get back to what I mentioned on Monday, that I want to teach you the best Python to start. And this is not the best Python. So let's understand why it's not the best Python and how to write things properly. So you see how things work. We start with a list of numbers, right? 0, 1, 1, 0, 1, let's say, right? And then we create, with this list comprehension, right, the list of everything of the form str of e for e in tape, we create a new list of strings, right? And you can imagine behind the scene, Python, say, okay, you want a list of strings, not too hard. I start with an empty list. I go to the first element of tape. I find 0. I apply str to that to get the string 0. That becomes the new first element of the list you want to get from me. Then I get to the second element, right? And then just stop these noises if you can. Get to the second element 1, create the list 1, then get to the third element 1, get the string 1, right? All the way to the end. And eventually, I've got the list of strings, right? So I have to read this whole list to create a new list. And then the join function, so this dot join, apply to that, See, creates now, by putting all these things together, a new string, right? Clearly, it's not very efficient, it's not very elegant, right? Because we think, why not instead create the big string, right, by not going through this intermediate step of creating a list of strings, right? Why not instead create a big string by going to this first element 0. So I want to create a string, okay? So the first element of my string will be what? I go there, I find 0. I convert that to the character 0. Okay, I have the beginning of my string. Then I go there, I find the number 1. I convert that to the character 1. That becomes the next element of my string, and so on, right? You see? Without having to construct in between a list of characters. So that's what we should do, and that's what we can do, as follows. So instead of writing this between square brackets, I write the same thing, but between parentheses. What is X? Something that looks complicated. A generator object. So essentially, X is Python code where we have put in place the mechanism to generate everything of this form on demand, right? So we haven't created a list of characters. We are just ready to generate each and every member of this list on demand, right? So how do we generate that on demand? By calling next. So when I call next X, this thing starts working, so goes to the first element of tape, finds 0, and gives me str of 0. And then stops. So it stops at this point in my list tape, right? Now, if I want another element, I call next again. And I get the next element. And again. And again, and again, and again. All right, so generate now 0, 1, 1, 1, 1, 4 ones. I make this a bit too long. There are still 5 elements left. Right? Imagine how things can work, right? That this mechanism visits your list tape to give you the next element you want, and then waits for you to ask for the next one. What will happen if I call next again? There's nothing left in tape now, right? So next just says, I'm done. It generates what is called a stop iteration exception. This is a way to say there's nothing more to give you. I gave you everything I could. Right? So how can we use now this nice thing? We can use a list of, so if I start again, if I define X this way, as I did, and call list of X, I get the same thing as what I get directly with the square brackets. So imagine how things could work. This list function gets this generator object as an argument and starts calling next, right? Until next returns stop iteration, at which point it knows that it got all the members of the list, and it gives you that, right? So you see, list doing behind the scene what we just did before, right? Calling next, 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 creating a list on the way as it goes, and eventually having all elements and terminating. Okay. So now we can do the same thing with join. So join does not only accept a list as argument, but it can accept as argument anything that iterates. So in particular, these generate expressions. So if I call join, vertical bar join of x, see exactly the same thing as if I pass the list. I don't pass the list, I pass the mechanism to access on demand all members of the list. Okay? So now, if I don't want to write things this way, I can pass an argument, this. Right? I pass an argument to join, this generator expression, which makes join happy. And Python now, because it's not very nice to have these two parentheses, so Python lets me actually omit the parentheses around the generator expression and write this. Right? So you see, it's both shorter, more elegant, and more efficient. Right? So understand what's going on. Here you see join taking as an argument a list, so a constituted, actualized sequence of elements. And here you see join taking as argument this generator expression, leaving the parentheses surrounding this expression implicit. Okay? So now I guess we are ready to use this to terminate our implementation of display tape, right? We still have to display tape contents. So we want to print this, right? And we say plus a vertical bar at the beginning, plus a vertical bar at the end. One extra parenthesis there. Display tape. There we go. Right, let's move that above. Okay, so we have called this helper function, beginning and end, in between what we just came up with. This is good, but not perfect, because actually, see, we create now a single string from the three strings, vertical bar, the big stuff, and vertical bar. And we don't need to do that, because print accepts us not only one argument, but as many arguments as we like. So we can just instead say, well, let's print a vertical bar, then the complicated stuff, and then a vertical bar again. Good? Not quite? What's not good? Yeah, we have a space. Because by default, print puts a space between successive elements, right? So we say first print a vertical bar, then by default a space, then the complex stuff, then by default a space, then the vertical bar. But we can change this default behavior by saying, as separator, instead of using the default space, let's use Yeah, empty string. Right? So don't put anything between the arguments. And now things work nicely. Okay. Fine. Okay, so I guess we are done now with the tape for now. Now, of course, the big thing is the Turing machine programmer. Right, the program of the Turing machine. Remember, we're playing with things like this. That's stored in a file. So I guess we need to read the contents of this file and then use it wisely, right? We want to simulate our Turing machine, so we want to apply these instructions properly. So we have a file stored in the same directory as where I'm working now. I'm working here in this stupid notebook sheet. And in the same directory, same folder, I have this file. So I can open this file. So I call the open function. And the open function returns something, x. I can see what it is. And then I can close x. Not close. What is it? That's not how it's supposed to work. It's supposed to be apply the close method to x. So what do we do here? Okay, we provide as an argument to open the name of the file where we have the interesting contents, and open within something we don't understand, right? Something thanks to which we can work and access the contents of the file, thanks to which we can read, right? So I guess we're going to apply methods to x to read the contents of this file. When we are done, we close it. Things could go wrong. So instead of using this syntax, where maybe we won't be able to close the file properly, it's advised to use another syntax, which is with x equal to, open this as x, and do something with x. All right, so it's exactly the same as before, except that close is done automatically thanks to this syntax. And in case something goes wrong, Python will do something very smart and make sure the file is closed properly and so on. Right? So that's always what we should use. So that's something you have to remember, right? When we want to open a file, we use this syntax with open name of the file as whatever, and then we're going to work with whatever. Okay, that's the proper way to operate. So what can we do with x? Of course, we would like to read the contents of the file, right? So, well, x, this object returned by open, this particular thing returned by open, has a number of methods we can apply, right? One of the methods is read lines. So what does this method do? It returns a list, right? You see the square brackets, right? Whose elements are all the lines in our file, right? As strings, right? You see the single quotes, it says it's a string, right? So the contents of the file, every line represented as a string. And what is this \n? That's a new line character, right? So you see, we have in particular here an empty line. It's not really an empty line, it's a line with just \n, right? Here it is. Right, so easy way to read the contents of a file. It's not a very good way, because if the file is huge, you are going to create a huge list, right? And it's usually much better to read the file line by line. Well, that's possible too. Instead of read lines, we can apply the read line method. It gives us the first line. So if we could read line 1, 2, 3, 4 times, we get first, second, third, fourth line. Right? Actually, X is a particular kind of generator object. We have seen before this general expression, right? X for str of X for X in tape. Well, you see, instead of doing this, I can call next of X instead. Exactly the same thing. But we see that X is actually something that, again, is a mechanism to generate on demand, right, all the lines by calling next. So you can think of read line as just syntactic sugar for next behind the scene. Okay? All right. So a nice way now to read all the lines one by one is to use a for loop. So with this as X, for line in X, print X. But print X, but print what do we want to print? Line, of course. X is this object, right? Okay. So imagine what's going on, right? So for line in X is essentially saying, okay, I have X, which can give me things on demand, right? Thanks to read line, thanks to next. I'm calling next, right, to get the first line and do what you want me to do, which is to print it. I'm calling next again to get the next line, do what you want, which is to print it. And eventually, I'm going to call next again. I will have read all lines. Next, we return stop iteration. I will terminate. All right, so you see, for nicely calling next behind the scene until there's nothing more to be given by X. Fine? So what do we observe? Are we happy with this output? Do you think it's same as this? What's wrong? Yes. That's why we have extra lines. Why is that? Because print, by default, prints a new line, right? And all our strings end with \n. So we have the \n that comes from the string and the \n that comes from print. So again, print has a special keyword argument. We have seen sep before, right? We have end, which lets us change the default, add a new line to nothing. Right? And now we've got what we want. Fine? Now these lines are all good except the first one, which is a comment, and the second one, which is empty line. All right. So I guess we just want to ignore these lines. So how can we ignore these lines? For the first one, you see that this line starts with a hash, which indicates comment. Well, Python has, if I type dir str, I'll get all the methods that str has to offer. I have a number of special things I can ignore. I guess everything of potential interest is there. I can capitalize a string, I can center a string, I can count, I can do all kinds of things. So if I want to see if my string starts with a hyphen, is there a particular method? Yeah, something called starts with. So I can ask if hello starts with capital H. The answer is true. Lowercase h, the answer is false. Does it start with capital H-E-L? Yes. Capital H-E-M? No. What about this? Does it start with the empty string? Yep. Start with the empty string. So in our case, what we want is to see if a line like this starts with hash, right, or not. Okay? Then we have these lines which happen to be empty, but maybe I could type some space to find if there is some space in our string. We have as a particular method is space. So if I ask if hi is space, the answer is false. Is space. If I put plenty of spaces around, it's still false, right? But if I put nothing but spaces, it is true. And I could add a space, new line, tab character, all that is considered as space, right? What about this? Is it true or false? Empty string. False. It depends if we mean everything is a space, and there is at least one space, in which case it should be false, or everything is a space, and maybe there's no space, in which case it should be true. So I guess I would actually prefer true, but it's happened to be false. So it means everything is a space, plus there is something. Okay, so we can get back to this. And say, for line in X, I want to print line only if my line is interesting. That means does not start with a hash and doesn't consist of nothing but spaces. So easy, right? If it is not the case that my line is nothing but spaces, and it is not the case that my line starts with a hash, then I print. Otherwise, I ignore. Right? So you really have to force yourself to read that naturally, right? If it's if my line, it's not the case that line is nothing but spaces, and it's not the case that it starts with hash, then I print it. Now we have eliminated these two lines, right? It's a bit hard to read because we have if not and not. And it might be nicer to say, well, if the line is not good, just ignore it. So we can do that too with this syntax. So I'm saying now, if my line is a space, so you have two ways not to be good, right? Either you are space, or you start with a hash. That means not good, right? If either I'm nothing but spaces or if I start with hash, I just want to ignore this line, so go back, ask for to give me the next line. So I can use for that continue, which means don't continue, which means go back, right? Go back would be a better name. So when we see continue, instead of continuing, we go back to the top of the loop, all right? So same thing. Some people don't like continue. Personally, I think this is nicer because the Boolean condition is simpler. And then you see we essentially discard what we don't want, and then we, at this point, do what is of interest to us. So instead of having a test, if this test is true, then we do everything we want to do. So you see how we indent, right? I don't spend so much time on that. That's something for you to figure out by yourself, right? But you see that when I have an if, I indent. When I have a loop, I indent. When I have an if, I indent, right? So you see, this way I don't indent as much, right? Instead of having print within an if, within a for, within a with, I have print only within a for, within a with. So it's also nicer in some way. Anyway, either is fine. Okay? Right, so now we have all the lines of interest. Of course, we don't want to print them, right? We want to extract what's interesting. So I guess what's interesting is, remember, what we get is, we print this, but what we get is these strings, right? So what do we want to do with each of these lines? I guess we want to extract the 5 components, right? The state, the bit, next state, bit, direction, right or left, right? We have to somehow extract that to be able to use it in some way. You see that all these things are separated by a space. Okay, so again, Python has a magic function that given a string such as 1, 2, 3, A, 4, 5, A, 6, 7, A, to this string, we can apply the split function with as an argument the glue, right? I want to say, give us the things glued together with A, if any. What are we going to get? I guess a list, right? The list of things glued by A. So what will that be? The string 1, 2, 3, the string 4, 5, the string 6, 7, and then we have A and A. So in between we have probably an empty string. And we have an empty string again to the right of this A, right? You see this A glues together 6, 7, an empty string. And this second A glues together empty string, and to the right, nothing, so empty string. Right? I can use more complex strings, so I can use ABC, ABC, split ABC. I don't know, ABC is the glue, right? So ABC separates 1, 2, 3 from 4, 5, from 6, 7. Okay? What is simplest and most interesting usually is to apply split to with no argument, which will mean any amount of space. I'm going to use the maximum of space, right? So high tab there, new lines. I don't want a dot. Thank you. All right, so if this is x, if I print x, you see, I print some space. Maybe might be clearer, right? So I print some space, high, then a tab, a bit of space, and then new line, right? And then after new line, exclamation mark, and some extra space. Okay. Well, if I call split on x, you see, I get a list with 3 words. So I get rid of all the space at the beginning, all the space at the end. All right? At the end, there is a number of spaces plus \n. No, not \n here, sorry, but could be 1. Or as many as I like. \n, \t, \n. Okay, no difference. All right, so I discard all the space at the end, all the space at the beginning, and all the space between words. Okay? That's obviously quite convenient. So let's print not line, but line dot split. Now, let's not use that. It's not relevant anymore. All right, so now you see, for every line, which is good, which I have not discarded, I print out the list obtained from each of these strings by splitting the contents, not looking at the spaces, right? So we're making progress into reading this Turing machine program. So is a list a good representation? So if you remember, the Turing program is deterministic, okay? And we can think of the first 2 elements as the input, right? What is the state? And what bit do we see, right? We have the head positioned under a single cell. We are in a particular state, and we look at this cell, right? It's deterministic. That means if I'm in state del 1, and I see a 1, there's only one instruction, right? So only one following state, new bit, direction. Right, so the first 2 elements are some kind of the input, right? What's the situation now? The next 3 elements are the kind of output, what will happen after I apply the instruction, if that's the instruction I have to apply. And since it's deterministic, a given input has a single output. So it is a kind of function, right? This is not a function because I have one input with 2 possible outputs, right? This is not a function. But this this is a function, right? Because every element from the domain has a unique element in the codomain, right? Of course, some elements in the codomain could be mapped to by more than one element. Okay, it's a map, right? Given this is what I get. Python has for this what is called a dictionary, right? So let's now work with dictionaries. D equal to, so let me map English words for numbers to the numbers themselves. So I map 1 to 1. I map 2 to 2. I map 3 to 3. That's the dictionary. And now I can ask, what does the map 1 to? Using this syntax, right? Same as for lists. For lists, we have seen we could use a number to say the position, the index. For dictionaries, we provide us between square brackets the key, okay, the member from the domain. So what does the map 1 to 1? What does the map 4 to? Nothing. So, of course, Python complains, generates a new kind of error now, key error, to say, sorry, this is not one of the possible inputs, right? It's not part of the domain of my function. It's not one of the keys. Now we don't have to have as keys a string mapped to a number. Okay? It could be anything mapped to anything. Well, it means to be seen. So what would you like D to do for us? Okay, let's remember, if we are playing with this, we want these two strings here to be the input, so the key, and we want these three things there, these three strings, to be the output, what to do if we're in this state, seeing this bit, right? So how should we define D? To say del 1 and 1 are the input. What do you suggest? So now I should go a bit too far. Of course, I can extend my dictionary, right? Now I can add 4 as a key and say I'm mapping 4 to 4. Good. So now D, you see, has one more key. And now, of course, I can ask, what is D of 4? Right, so here I created a dictionary with 3 pairs, right? But then I can expand my dictionary, or I can say, sorry, but D of 3 is going to be 300. D of 3, so now I'll have that as well, right? So see, I made a typo, so this 3 with only one E is there, and the 3, spelled properly, had its value changed from what it was at the beginning, 3, to 300, by assigning 300 to D of 3, right? So I can also change, I can add new keys with the corresponding value, and I can change the value of a given key that already exists, right? So here, what do we want to do with this? If we start with an empty dictionary, right? Empty list, square brackets, empty string, 2 single quotes, empty dictionary, empty pair of curly braces. Let's add now one element to take care of this input mapped, okay, the state and bit mapped to this triple. So what do you think? What should we use as key? The key should be del 1 and 1, right? So I guess it's natural to say let's map the list del 1 and 1 to the list of the three things that define what to do, right? If I'm state del 1 and 0, 1, I want to change to del 2, replace 1 by 0, and move to the right. So the key is the list del 1, 1. The value is the list del 2, 0, R, right? Doesn't work. So why is Python not happy with this? Because the keys have to be things you can't modify. All right, so number, you can't modify it. So that's why you can provide a number as a key to a dictionary. A string, also, you can't modify it. You can create new strings from this string, but you can't modify a string. So it can also be the key of a dictionary. But a list, you can modify it. Let's see. If L is the list 1, 2, 3, well, I can decide to append 4 to my list. And now my list becomes 1, 2, 3, 4, right? I can decide to delete, remove. How do you know if it's delete or remove? Dir list will give me all the methods for the list. Let's remove 2. 2 is gone. I can then change the first element, so of index 0 to 10. And now this is 10, 3, 4. Right? So I can modify my list both by adding elements, removing elements, changing the value of the elements I have. Now Python has something which is almost like a list, except that you can't modify it, which is called a tuple. So if I say t is equal to 1, 2, and 3, t is a sequence of elements, except that it's surrounded by parentheses instead of square brackets. If I try to append 4, see, complaints, it doesn't exist. I can't append anything. I can't remove anything. Complaints. I can't change the value of t of 0, the first element, to 10. Complaints again. All right? So tuple is like a list, except that it's much more restricted because once you have it, you can't change it. And actually, these parentheses are optional. So what actually defines the tuple is this. You see, I leave the parentheses implicit around 1, 2, and 3, and Python understands what I mean. I mean a tuple, and it shows that it understands what I mean with the output. Right? So 1, 2, that's the tuple 1, 2. Right? One, what is this? Is that a tuple? Look at the output. There's no parentheses in the output. That means that for Python, 1 is just 1 surrounded by parentheses. We need parentheses, right, if we want to compute 2 times 12 times 4 plus 8, or 12 plus 8, maybe. We get this result, meaning we first perform this computation and then multiply, right? That's what we do. So if we want to change the order of the operations, okay, we have to use parentheses. So we need parentheses sometimes. So that's why for Python, this is just 1 with parentheses for whatever purpose. So if I want to have a tuple, I have to put a comma. And now you see parentheses appear to say that's indeed a comma. All right? So if you have just one element, you have to put a comma. And if you put just this, it makes no sense to surround by parentheses nothing. So that has to be a tuple. All right, so nothing, parentheses, that's empty tuple. One element with a comma. And then if you have at least one element, you need a comma to indicate it's a tuple. All right, so that means instead of doing this, what should we do? We should change the key to that. All right, so we say this is, we put as a key a pair we can't modify, right? On the right-hand side, we also have to make it a tuple. No, because on the right-hand side, we can't modify it. That's fine. Okay, so Python is happy with this. It's also happy with that. Of course, we can make it a tuple. That's fine. If we don't have to, right? We have to make the key a tuple, but we can make the value either a tuple or a list, because the values can be modified. And you see, so if I put D, okay, that's D mapping this pair, this tuple with 2 elements to this triple. And again, Python lets us simplify notation by removing these pair parentheses. Remember, as I said before, it's the comma that actually tells Python it's a tuple. Right? And you see it in the output. So it doesn't mean I give to D 2 keys, right? It means I give to D 1 key. So there can be only one key that happens to be a tuple with a surrounded parenthesis just being left implicit. Fine? Okay, so let's get back to this. So what do we want to do? We want to define a dictionary, right? Instructions. To start with, empty. And then, when we find an interesting line, what do we want to do? We want to split this line. All right? Which is the instruction. Okay? Instruction is nothing but a list with the 5 strings that we have extracted by splitting our initial string, okay, thanks to the spaces. We don't want to print instruction. You want to add this instruction to the dictionary instructions, right? So instructions should now have a new key, right? What should be this new key? It should be the first member of instruction, right? Which is instruction of 0. It should be the pair, right? Where first element is the first instruction, second element is this, right? And then I put a backslash to continue my statement. The value will be instruction of 2, instruction of 3, instruction of 4. Let's see what instructions is eventually. What is wrong there? Just need to read instructions, typo, instructions. Right, so we see between curly braces, so we have a dictionary, right, where the keys are the first two strings as a pair, and when the value is the last three strings, also the tuple. And again, if you want to take advantage of Python syntax, let's keep this implicit. Let's keep this implicit. That's fine as well, right? Are we happy with that? It's not very nice to have instruction of 0, instruction of 1, instruction of 2, instruction of 3, instruction of 4. Okay. So we can do something nicer. We can use, okay, if I have a tuple here, or let's say a list. Right? So a list X with 3 elements, 1, 2, and third element is the list 3, 4. Why not, right? So that's X. Instead of assigning these to X, I can assign these to A, B, and C. And again, it means this. It means on the right-hand side, I have a sequence with 3 elements. On the left-hand side, I have a sequence with 3 elements. So I just make the first element on the right the value of the first variable on the left. The second element, the value of B. The third element, the value of C. And now I can see what are A, B, and C. A is 1, B is 2, C is 3, 4. Right? You see, if I write A, B, C, D, what will happen? Python will say, well, on the right-hand side, I have 3 elements. On the left-hand side, 4 elements. I can't do that, right? There is 1 element. I don't know what to do with it. So it's going to complain. Not enough values to unpack. If, conversely, if I just have A and B, again, this time, not enough elements on the left, so too many elements on the right. Right? So, of course, the number of elements has to be equal. I can even do something like this. Now, instead of saying C, if I know that C is actually a list with 2 elements, I could write here E, F. Right? So we assign 1 to A. We assign 2 to B. And then we assign the list 3, 4 to the third element on the left, which is fine, because this list has 2 elements. So I can assign 3 to E and 4 to F. Right? So you see, just the pattern on the left has to match what you have on the right. And it can work with lists, so same thing as before. I can leave that implicit. Right, so that's what we usually write, but it means that I assign one element, what's on the right, to one element, what's on the left, which is a tuple with the surrounding parentheses just left implicit. Right? So now, I guess I can do nicer things. Which is line.split returns instruction, so a list with 5 elements, right? And I can now say, well, let's just assign the first element of this list to state, the second to bit, new state, new bit, and direction. You see, I'm just doing what I did before, right? Make sense? Line.split returns a list with 5 elements, and I assign this list of 5 elements to this tuple of 5 elements, so element by element, leaving the parentheses implicit. And now I can say, instead of instruction of 0, instruction of 1, I can say state bit, right? The first 2 strings. And the value is new state, new bit, direction. Again, simplifying by just leaving all these parentheses implicit. More readable, right? Got it? I know it's a lot, right? You see, so my aim is, of course, to direct you to make reading the notes easier. But if you start feeling it's too much, that's understandable. It's a lot of syntax, right? So just don't drown, just understand enough, and then you can calmly read the notes and master that step by step. And of course, the quiz, we'll talk about it, is 100 times easier than this, right? So don't worry. Is that good? Any criticism on our dictionary? I guess del2 and R, L, strings, that's fine. But what about string 0, string 1? That's not great, right? Tape contains is a list of numbers, integers, right? So I guess it would be nicer to have here the string del2 and then the number 0 as a key, right? That we map to the new state, the string end, the new bit, the number 0, and the direction, the string R. Right, so instead we would like to have 0 and these 2 zeros here as ints. Is this difficult? Nothing is difficult with Python, of course. So we have seen before how to convert the number 2 into the string 2, right? Conversely, we can convert the string 2 into the integer 2, right? Convert number to a string, convert string to number. Of course, if the string represents a number. If you try to convert 2a, says I don't know how to convert 2a into number, right? So it has to be a valid representation. So what do we have to do? We just have to add int here, right? So, okay, line dot, not here, sorry. Okay, line.split returns these 5 strings. Now let me transform the second string into an int and make the first string and this int as a tuple, the key of my dictionary. And the value will be the triple, the tuple, with 3 elements. First, this string, then that string, and a second element in between, not the string new bit, but the integer I get from this string. So now a dictionary looks nicer, right? We have done the hardest work, I guess, which is to read this file and extract the contents in a way we can now use. Okay, so what do I want to do eventually? I want to show my tape. And say, to start with, we are looking at the leftmost one, in state del 1. Okay, so I would like to print the tape that we have done already, and just below the cell I'm looking at, write the state. That's what we start. Then my dictionary tells me if you're in state del 1, and if you see a 1, an instruction for you. Right? I have a key with del 1 and 1. And the value is, we place this 1 by 0, we go to the right, and we change to state del 2. So I then want to print this, where this 1 has been replaced by 0, otherwise it's the same. I have moved to the right, so I'm now looking at this cell, and under this cell, I write del 2. And do that until my computation is over. All right, so essentially what the widget does, but in a textual form. Got it? So I want to print not only the tape, but under it, at the right location, the current state. So let me now define the function, print configuration. Now this function takes an argument. So we have tape defined outside of all functions, right? So any function can use it. But here we define a function that, besides tape, is also going to get some input that's going to be used to do the work. So I want to print the current state at the current location. All right, so location as, this is location 0, this is location 1, okay, this is location 0, location 1, location 2, location 3, location 4, right? So if I know the tape from outside, and I give my function what is the state I want to print, the string del 1, what is the position, position 2, then I guess the function should be able to print the tape and then print del 1 at the right position, right? So how? What does this function do? First, it prints the state, right? It prints, so it calls the function we defined at the beginning, display tape. Right, so let's execute this function. Okay, and then what we need to do after that is to print. What do we have to print? This input, the state, right? We need to print this input, But if you do that, well, let's try it. If I play print configuration, so del1 at location 3. So I display the tape, here it is, and then I just printed current state, which I made equal to del1. What do I need to do? I need to put it not at the very beginning, but at position 3. So I guess I need to print first the number of spaces. How many spaces? That's position 3. For position 2, 1 and 0. I have 2 spaces, right? Vertical bar 0, vertical bar 0, vertical bar 0. So position times 2. And then I have 1 more space, but printing a space by default between arguments. I guess I only need to print two spaces times I. Times not I, but current location. Right? If I make the first argument equal to 0, then I print at the very beginning. I make it equal to 1, 2, then print whatever. Got it? So we have now all the tools we need, I guess. Let's redefine tape. Let's say we define tape. So we know our program works. We know we don't need many zeros before. Let's say we want to divide 7 by 2, right? We are working with a division program. So this plus 7, 1. And we know that 2 zeros to the right is more than enough. What is the current state? The current state is del1. We know it, right? This is hard-coded. We know that we start from del1 as the initial state. Okay? Current state is del1. Where do we look at? So current location. Here we say it's 3, but with this definition of tape, what should be current location? It should be 0, 1, 2, right? Look at the leftmost one. Okay? How do we not hard code it? Well, we can use the index function, L.index 0. Not L, tape. That means what is the location of the first occurrence of 0? It is position 0. What is the location of the first occurrence of 1? It is 2, right? What is the location of the first occurrence of 2? That's where it generates an error saying, sorry, but 2 is not in the list. Right? That's exactly what we want, right? Current location, to start with, is the location of 1, the leftmost occurrence of 1 in our tape. Okay? And we can print configuration with the state, current state, and with the location, current location. Okay? That's fine. So now what do we want to do? We want to do if there is an instruction that tells us when you're in state del 1 and you see a 1, have something for you to do, right? How do I find this out? I can ask if del 1 and 2, this pair, is in one of the instructions, one of the keys I don't want location, right? My instructions don't work with locations. They work with bits. So I guess I also need current bit. What is current bit? Well, we know it's 1 when you start with, but if you don't want to hard code it, we can say it's the location of, it's what's in my tape, a current location, which by very definition, well, that's a bit of a killer, right? Because we assumed before that we see 1, so we have a 1, so the current bit, what we see to start with is 1, okay? And I have instruction that tells me if you see a 1 in state del 1, yes, indeed, I have something for you to do. But if you see a 0, also something to do. If you see a 2, I have nothing for you to do, right? And actually, we don't need this. Instead of asking, is this one of the keys of the dictionary, we can just ask, is this in the dictionary as a key? All right, so no need for dot keys. That means, is that one of the keys of the dictionary instructions? So in case, indeed, we have something to do, what we have to do is given by instructions of del 1, 1. When you do a typo, you do it again and again. Okay. So we get the value of our dictionary for this key, right? It says, in this state, you have to change to del 2, you have to change the 1 to 0, and you have to move to the right. Okay. So in other words, so let me start again. No, we don't need to start again. I need to say that since current bit and current state is one of the keys of instructions, I can ask what I have to do with this state and this bit. Current bit, not defined. I deleted it, stupid me. Right? So that returns a triple, right? With first element, which is the new state, next element, which is the new bit, and the third element, which is the direction. Right? And I print new state, new bit, direction as a triple implicitly. Curly braces. The curly braces are left, the parentheses are left implicit. So what do I have to do? I have to change the bit to the new bit, right? How do I do that? In my tape, I'm now looking at current location. Now, this would return current bit. I want to change that to new bit. Then I want to change my state to new state. So I want current state to be new state. And then I want current location to be equal to what it is now plus 1 if the direction is equal to right, and else I want current location to be current location minus 1. Are we all done? We have updated current state. We have updated current location. Have we updated everything? Look, to work, we work with current state, current location, and current bit, right? How do we update current bit? It's now what we look at, right, in tape. Current bit becomes what we look at in our tape at what is now our new current location. Let's see, current state, current bit, current location, and let's print configuration of all of that. All right, so indeed, new state is del 2, that's fine. Now we're looking at the next bit, which is 1, at position now 0 and 3, in state del 2. Okay? In state del 2, looking at 1, is there something for me to do? Yes, because del 2, 1 is one of the keys of the dictionary. So I guess I can do exactly the same thing. And now I have deleted the second one. My position has become 4. My new state has become move 1 R. All right? So you see, this is what I want to do again and again and again. Right? As long as the current state and the current bit is a key of my dictionary. So as long as I have an instruction to execute. So we are there now. We have done the hard work. So let me summarize everything. We start with this tape, and then we want to say that for as long as, well, we have seen one kind of loop, for loops. There's another kind of loop, which is the while loop. So while, so as long as some condition is true, what condition should be true? As long as current state and current bit is one of the keys of my dictionary. All right, so first I print configuration with these to start with. Then I execute all that. So since it is in a while loop, I have to indent. You see, so as long as this pair is a Kerfman dictionary, I do what we have just done, again and again and again. And when I get new current state, current bit, which will not be a key of my dictionary, I will be done. So at every iteration, I want, of course, to print configuration. And there we go. Except that list out of range. What's wrong? I didn't have enough. Yeah, if you remember how this division by 2 worked, we had to the right of the input a separating 0, and then enough space to copy the output. So of course, if I divide 7 by 2, I should get 3, so this 2 zeros is not enough. So let's put 10 or 6, just to be safe. And now I terminate in the state end, looking at 1 for which there is no instruction. Right? Make sense? So it's a lot. So it should be really drowning with too much stuff. But now you should get, it's already 80% of the core of Python, right? It's, with that you have seen tests, loops, pretty much everything, right? So you can be proud of yourself to be at this stage. So let me, any question on that? So let me talk about the quiz, right? I guess we have to calmly talk about what is assessed. So if you go to assessments, I'm going to release the quiz. And it comes with a stub. That means some code already there that you can understand, but you don't have to understand. We'll see that later. Essentially, I'm asking you to input 2 integers. The first integer will be used by some random number generator to make the random sequence deterministic for me, so I can test your program knowing the sequence of numbers are going to generate. The second number is going to be used to determine the length of the list I want to generate. And your job will be to work on this list called values. So the PDF shows you sample tests, right? So if you input 0 and 2, is generated for you a particular list with 2 elements, 4, 4, all right? With a different first number, it will still be a list with 2 elements, but it will be different, all right? But by fixing the first argument of 2, I always get 4, 4. So you work with that. You have a list called values, which is equal to 4, 4. And your job is first to printf statement with a string, the difference between last and first values is, and then values of right index minus values of right index, I guess, right? Something like that. Difference between last value and so 4 minus 4 is 0. Then you have to represent this list with stars, so 4 and 4, and then vertical stars, 4 and 4 with the surrounding frame. All right, so now if we have another input, 0, 4, this time I have a list of length 4, which happens to be 4, 4, 1, 3. So you have to output the difference between last and first value is, and then 3 minus 4, so minus 1. Then you have to show me 4, 4, 1, 3 stars. And then you have to show me 4, 4, 1, 3 stars, vertically this time, surrounded by a frame. Right? So you can work locally, you can work in head. So I can run this program, generate 0 and 4. So this is generated by me, right? This 4, 4. I execute this print statement. And here you have to execute your code, right? You have to insert your code so that the output, state, so that the output is this, right? So at this location, you insert these print statements to get that output. Then this is printed there. And now you need to insert code here to generate that, these 2 lines, right? So now if you click the mark button, which also means submit, and you can submit as many times as you like, of course. I'm going to fail the test. It shows me it starts well, it's done already, but you see, plus green and plus means this is what should be output, and there is nothing that corresponds to that in your program. Then I want to see that, I'm happy I see that, but then I should see that I don't see it. All right, so now if I insert code, print happy with this, values of 2, so I can run 0, 5, happy with this 1, and then you can mark Why is that? Because I'm using here, as example, a list of length 2. So the value indices are 0 and 1. So values of 2 is invalid. Now if I make values of 1, mark. Now you see you have a diff. First line should be fine. It's a technical reason why I showed the first line as not good, but so you see now the diff. Red, your output, which doesn't match green, the expected output. All right. So the aim, of course, is to pass this. Is not only to pass these sample tests. It is to write a correct program, because of course I'm going to use other tests, right? I'm going to use other numbers. Okay, so you should not only look at these sample tests and say done, you have to think to test your program to make sure it's robust. So how are you going to test your program? What will be? You have to test the simplest cases first, because we often make errors with the simplest cases. What is the simplest case here? What is the simplest case? Well, you see, I reject a length of 0 or less. So that's fine, that won't be tested, right? So the minimum length is 1. So I guess that's a special case. What happens if you have a list with just one element? So you should test that, right? So of course you can work outside of head, right? And what you could do is, instead of hoping to get interesting values by chance, what you can do instead is to comment this out. Not too sure to comment things out in add this way, because I never do that, but obviously not that. Well, you insert a hash symbol, right, to comment out. And then you make values equal to what is interesting. Let's try with just the list 2, right? Of course, you won't pass the test, but because the output is not what is expected, but that's for you to test that the program is robust, right? So, okay, let me try with a list of length 1, just one element. Then let me try with a list of length 2. Is that all there is to say about lists of length 2? A number of cases. What are the cases where the two elements are the same? Right? It doesn't matter what it is, I guess. So 1, 1. Let's test this. They're not the same. So maybe that the first element is less than the second one, or maybe that the first element is greater than the second one. Right? See, you start systematically. You test systematically for a list of length 1, length 2. 3, you can probably do it as well. It's just 6 possible cases, right? And then arbitrary lists. Right? So you have to, from now, take the discipline to test your programs and not think that you just have to pass the sample tests. So now, if you are experienced programmer, of course you do that in 5 minutes. You're done, right? If you are a beginner, that will take you hours. That's perfectly fine, right? We all have to go through this. So start thinking about it tonight and start working on it tomorrow, the day after, and go to consultation if you are stuck, right? We have consultation, have a look at the course outline, by all means, get support. But if you start now, you can afford to be frustrated, you will be frustrated, put that on the side and get back to it the next day when the ideas will be clearer, you will make a bit of progress and will be fine for when it's due, which is Friday noon next week. All right, so make sure, and before you do that, read the lecture notes, right? So do things in the right order, master more of the techniques, the syntax, which is much more than we need, but start working on the quizzes, okay, soon enough so that you can work step by step without being overwhelmed with frustration. Any questions? Yeah. So you can try as many times as you like, right? I will test your I will let your program run for 30 seconds for each test. Of course, don't need that much time for this. Even if you make it most inefficient, that can't take more than a fraction of a second, right? But the rule of the game is I run your program against a battery of tests, and as indicated, you get marks for half a mark for the difference, 1 mark for horizontal bar, 1 mark for vertical bar, as a total, right? So if there are 10 tests, that means each test will be worth 0.05, 0.1, 0.1, right? And then you score the mark for all the tests you pass. Even though you should get a full mark or 0, because if a program is sometimes incorrect, it is incorrect. So you should not get partial marks. But if I do that, you get too upset. So you get partial marks. No other question? Okay, so see you next week.
It's the one you get in the